Today we're looking at section 2.4, writing linear functions. Our objectives are to be able to write linear functions in slope-intercept, standard, and point-slope form when given information such as equations, points, slopes, and graphs, and to be able to write the equations of parallel and perpendicular lines when given information. We talked about three forms for the equation of a line: slope-intercept form, standard form, and point-slope form. We're going to be working with all three of these today. First equations, our first couple problems ask us to change the following equations and put them into standard form. Standard form is our ax plus by equals c, and typically for most books they like a and b to be integer values. So we're going to try to get this as far as x's, y's, and then our constants on the right hand side. So the first thing we're going to do is add 3/2 x to both sides. And since we usually typically put the x first, I'm just going to write that first, plus 8y equals 5. Now 8 is an integer value, but 3/2 is a rational value, or a fraction. So since most standard forms want these to be both integer values, which we talked about in the first lesson, what I'm going to do is multiply each term by a 2. And in doing that, I'm going to get 2 times 3/2, which is 3x, plus 2 times 8y is 16y, equals 10. And now both a and b are integer values. If we look at example 2, this is actually point-slope form, but again I need to change it to standard form, so I'm going to distribute the 5 first. Get 5x minus 10. But I know the x's have to be on the same side as the y, so I'm going to subtract 5x. And then rewrite everything else. And then for my last step, I'm going to subtract 3. A and b are both integer values, so I'm done. The next examples ask us to write the equation in now slope-intercept form, which is y equals mx plus b from a given graph. So we need to know two things. We need to know our slope and our b value, our y-intercept, for both problems. In our first example, the easiest thing to see first is our y-intercept. Our y-intercept is actually at the point 0, 2, which means our b value is a positive 2. To find slope, we need to pick 2 points. So if I look, there should be a point right about here. And if I ever ask you to find the equation of a graph, the equation of a line from a graph, you can assume that these are going to go through exact points. And I know sometimes drawing the line, it's off just a tiny bit depending on how it prints, but I'm never going to ask you to find decimal values. So my slope is my rise over my run. So I'm going to go up 2, which is a positive 2, and left 3, which is a negative 3. Now that I have my 2 parts, I'm going to write y equals negative 2/3 x plus 2, and we typically put the negative in the front. In our next example, our b value is right here at 0, 5, so the b value is actually 5. And if I look for the slope, I'm going to look for another point. My rise, if I'm going from 5 to 9, is up 4, so it's a positive 4, and then I'm going to go to the right 1. So 1. You don't have to write the 1, but for our slope it might be a little bit more helpful. When I write my equation, though, since my slope value is 4, I'm just going to write 4x plus 5. Okay, let's look at our next examples. Write the following linear functions in slope-intercept form. Again, slope-intercept form are y equals mx plus b. And the first time they give me a point and a slope. So this would be really easy to write in point-slope form. And actually, that is what I'm going to do first. I'm going to take this. This is my x1 and my y1. And I'm actually going to just do y minus my y1 equals m times the quantity of x minus my x1, which I can change to a positive 9. Now, even though it didn't say put it in point-slope form, this is a much quicker method to get it into slope-intercept form. I know probably in Algebra 1 or Algebra 300, everyone did y equals mx plus b, you substituted in the m, you substituted in the x and the y, and then you solve for b, and then substituted everything back into the equation. This is a way to do all of that in 2 steps, and it saves a lot of time, and I think it's a lot easier. So if I want to get this into y equals mx plus b form, the first thing I'm going to do is distribute to 2/3, which is 2/3 x plus, when you multiply fractions, I'm going to just make this a fraction and multiply the numerators, which is 2 times 9 is 18, over 3 times 1 is just 3, so 18 divided by 3 is 6. And now if I just add 7 to both sides, I now have it in slope-intercept form, which is a much quicker method. But what happens if I'm given 2 points? Well, remember, slope-intercept, I need to know the slope and the intercept. Hopefully remember that slope is rise over run, or the change in y. That's how we do the change in delta over the change in x. So what we're going to do is take my first y and subtract my second y. I take my first x and subtract my second x. So this is going to give me a positive 4 over a negative 8, which gives me a negative 1/2 for my slope. Well, now that I have slope and I have points, I can do the same thing I did in example 1. Now, it doesn't matter which point you pick. I tend to like to not have to worry about negatives as much, especially since my slope is already negative. So I'm going to use the 0.61. Y minus, and this is x1, y1. Y minus y1 equals m times the quantity of x minus x1. They do the same 2 steps I did in the last example. I'm going to distribute the negative 1/2. And when I distribute 2 negatives, make a positive. 6 divided by 2 is 3. And then for my last step, I'm just going to add 1 to both sides. And I get y equals negative 1/2 x plus 4. Let's look at our next examples. So now we're going to talk about parallel and perpendicular lines. First, parallel lines. So hopefully you remember from geometry that they are coplanar lines. Okay, and what coplanar means are 2 lines that lie in the same plane. So think of a sheet of paper, 2 lines you can draw on the same sheet of paper that do not intersect. So, for example, those 2 lines, given if they were straight, they go on forever, will never intersect. So what has to be true for them to be parallel lines? Well, to be parallel, we have to have the same slope. And not only that, we have to have different y-intercepts. And the main reason for that is because if we had the same y-intercept and the same slope, they would be actually 2 lines right on top of each other, which would not be parallel because they would intersect infinite number of times. So most people just say same slope, but you also have to know they have to have different y-intercepts. Our symbol, for example, if this is line A and this is line B, the A is parallel to B, so it's 2 lines straight up and down. Perpendicular lines, coplanar, again, lines in the same plane that intersect to form a right angle. So I can draw lines any direction I'd like as long as they form a right angle. And if you remember from geometry, we put this little box. That's the only way you know for sure that they form right angles. So hopefully you remember that they have what we call opposite, reciprocal slopes. Okay, so what that means is if one slope is 2/3, the other one is negative 3/2. The negative is the opposite part, and the reciprocal is flipping the fraction. What if the first one was negative 5? Well, let's look at this as a fraction. That means the next one would be a positive 1/5. Now we have some special cases. What if we have a horizontal line? A horizontal line has a slope of 0. Okay, no slope. But we know the perpendicular to that would be a vertical line. Well, what's the slope of a vertical line? Well, a slope of a vertical line is undefined. So that doesn't seem to follow the rule over here. Well, let's think about that. 0 is just 0 over 1. Well, if I do the opposite reciprocal, I get negative 1 over 0. And we should remember that we cannot divide by 0 because it's undefined. And that's why this still holds true. A horizontal line, slope is 0. Its vertical line is undefined. So they truly are opposite reciprocals in the same manner. Hopefully you also remember that if this is line A and line B, line A or B, that our symbol for perpendicular is an upside down T. So you're going to see that on your worksheets. Let's go through a couple examples. We have write the following linear functions in slope-intercept. We want to find the line parallel to y minus 4 equals 3 halves times the quantity of x plus 5, and it has to pass the point negative 4, 1. Let's first concentrate on the fact that it said parallel. What do we know about parallel lines? One, they have to have the same slope and different y-intercepts. So if they have to have the same slope, let's think about what the slope is of this line. We know our slope has to be 3 halves. Alright, so now I know the slope, and I know a point it has to go through. Negative 4, 1 is my point. Well, I'm going to do the same thing I did earlier. I have point slope. So I'm going to do y minus my y1 equals the slope. And again, just to reiterate, this is y1, x1 and y1. So times the slope, 3 halves, times the quantity, x minus whatever x1 is. Well, double negative, we'll make that a positive. But it said in slope-intercept form, y equals mx plus b. So I'm going to take my 2 steps. I'm going to distribute the 3 halves, make this over a 1. So I get 12 divided by 2 is a positive 6. And then add the 1 for my last step. And that is the equation of the line that's parallel to this, so they have the same slope, but goes through this point. Our next example says, write the linear equation again in slope-intercept form of the line perpendicular. So again, if we remember, perpendicular lines have opposite reciprocal slopes. So it's going to be perpendicular to 4x minus 2y equals 1. Where that negative came from, sorry about that. And passes through the point 8, negative 6. Well, this is in standard form. You can't just look easily, and some people can, but it's not easy to tell what the slope is. But I can solve for y. So what I'm going to do is subtract 4x from both sides. So negative 2y equals negative 4x plus 1. And then I'm going to divide everything by a negative 2, which gives me a positive 2x and a negative 1 half. Now that it's in slope-intercept form, I know that my slope is 2. But I want the line perpendicular. Perpendicular lines don't have the same slope. I know that the slope of my perpendicular line, so slope of perpendicular, should be the opposite reciprocal, so negative 1 half. And I know the point it goes through is 8, negative 6. So I'm going to do like what I did before. I'm going to do y minus y1 equals my perpendicular slope times the quantity of x minus x1. And I'm going to solve for y. I'll make this a plus. Y plus 6 equals, distribute the negative 1 half. Negative 1 half times negative 8 is a positive 4. And then I'm just going to subtract 6 from both sides. Which gives me y equals negative 1 half x minus 2. Again, now they're changing up the information they're giving me. We still want to write the equation in slope-intercept form, but it has to contain the point 6, negative 1 and be parallel to the line with the points 1, 3, and negative 2, 5. So they're making it a little bit harder to find slope, because again, parallel lines have the same slope. So if I can find the slope of 1, I know it's the same for the one I want. So how do we find slope here? Again, it's the change in y over the change in x. So I know I take my y minus the second y, and I take x minus the second x. So that gives me a negative 2 over 3. And since I know the slopes of parallel lines are the same, I know the slope of my parallel line is also negative 2/3. And I know the point it goes through is 6, negative 1. So I know y minus y1 equals m times x minus x1, the quantity x minus x1. So I'm going to make this a plus. Y plus 1 equals, distribute negative 2/3 x. 2 negatives make a positive. It's going to be 12 over 3, which is 4. Get negative 2/3 x, subtract the 1, and get plus 3. And again, what if I now ask a similar question but for perpendicular? Okay. No matter what, I need to know the slope, and I know to find the slope of my line, it'll be the change in y over the change in x. So I'm going to take y1 and subtract the second y, y2. I'm going to take x1 and subtract x2. Negative 2 minus 4 is negative 6. 5 minus 5 is 0. So this should throw off some red flags. Negative 6 divided by 0, that's undefined. Okay. Oops. What will we get there? Okay, undefined. So what does that tell me? What kind of line has an undefined slope? Well, it must be a vertical line. Oh, and let's see if that makes sense. Well, this one's at 5, negative 2, and this one's at 5, 4. And going back to our lesson on relations, we should know that this is not a function because our input has two different outputs, which lets us know it doesn't pass the vertical line test. So that's because it is a vertical line. So if this line is vertical, and I want to find the one perpendicular to it, I must know that my perpendicular line is going to be horizontal. And what's the slope of a horizontal line? Well, it's 0. So now I know the slope, and I know it has to go through the point 9, negative 7. So let's think about this. I have point slope. Let's do y minus y1, negative 7, equals slope times x minus 9, the quantity x minus 9. So this is kind of a weird one. So let's see what happens when we solve for y. We get y plus 7 equals, anything times 0 is 0. But we know when we solve for slope-intercept form, y has to be by itself. So I get y equals negative 7. So let's think about why that is. Well, remember, we said our answer is a horizontal line. And if you remember from our last lesson, the slope of any horizontal, the equation of any horizontal line is always y equals a number. And if it's horizontal, we know the y value at every single point on this line is the same. And if we know the point 9, negative 7 is on that line, and we know it's 9, negative 7, then the y must also be negative 7 always. And it's kind of a quicker way to do it, but if you don't know that, you can just always write everything into the equation. So what do we have to do if we're going to do two more examples, writing an equation of parallel from a graph? So all we have to do if it's from the graph, we have to look and find the slope. Well, I can look here and pick any 2 points, and I know the slope is 1. So if I know the slope is 1, if my parallel line is 1, I can just do y minus y1 equals the slope times x minus x1. So y minus 5 equals x plus 2. And then I'm just going to add 5 to both sides. So I'm going to get x plus 7. Now let's think about that in the graph. If I graph this, I would have a point at 7 and a slope of 1. And if I graph this, you should see that I'm going to get a parallel line, and that's a good way to check. What if I wanted a perpendicular line? Well, let's think about what the slope of this perpendicular line is. I have a point here and a point here. My slope is up 2, left 1, negative 1. So if I know that slope is negative 2 over 1, I know my slope of my perpendicular line is the opposite reciprocal, so it's going to be a positive 1/2. And it goes to the point 3, 0. So I'm going to do y minus y1 equals the slope times the quantity of x minus x1. So this is just y. It cleans up nicely. I'm going to still have to distribute 1/2 x minus 3/2. And that's my equation. Now this doesn't graph as nicely, but if I was going to graph down, negative 3/2 is negative 1.5. So we'll go down 1.5. And then from here, I'm going to go up 1, right 2. Up 1, right 2. Well, if I go down 1, left 2, down 1, left 2, I keep doing this. Although it's not perfect, because it's hard to tell in here, it should look like these two lines form a right angle.